Today we're going to look at how we solve linear inequalities. And inequalities are any sort of equation, even though it's not an equation, that has a less than sign, a greater than sign, a less than or equal to sign, or a greater than or equal to sign. So there's some babies crying. Great, fabulous. But if you look at these inequalities, and pretend that it was a equality, okay? For every x that you put in, let's say we put in 0, there's only one y. Now if you look at the inequality part though, right, and we put in 0, right, so if you look at this as a separate thing, if we put in 0 for x, right, so we're trying to find some number that's less than 0 minus 3. Somebody's kid just won't be quiet. Oh, there, they beeped it. Okay, so y is less than negative 3. There's actually lots of different answers that would work, right? Negative 4 would work, but if you have 0, negative 5 would work, negative 6 would work. There's an infinite number of answers that might work, so it's a little bit different than an equation. So the way we'll solve these is by to actually graph all the numbers at work. We're going to graph the solutions. So here are the steps. Okay, the first step, we're going to graph it as if it is an equation. So you can go ahead and write y is equal to 2x minus 3, and we're going to graph that. So you can use points, 0, negative 3, 1, negative 1, and 2, 1, or you can use slope-intercept to figure that out. Okay, there's our line. So it goes through 0, negative 3, and has a slope of 2. Now the second thing we want to do is decide whether or not it's going to be a solid or a dotted line. So the way we do that is we look at the inequality sign. So if it's a less than or a greater than sign, it's going to be a dotted line. And if it's a less than or equal to, or a greater than or equal to, it's going to be a solid line. So in this case, it's going to be a dotted line. Now this is going to be difficult to show with this particular graphing program, but you can just go ahead and erase the space on the lines to make it dotted. Or as you draw the line, you can just make it dotted. The reason this is we want to look at, let's pick a point on the line. Let's pick 0, negative 3. Okay, and let's try to put it into there as a solution. So if we do negative 3 is less than 2 times 0 minus 3, we see that we get negative 3 is, that's 0, right, less than negative 3. Now, it's really close, right? Anything a little bit more would actually be less than negative 3, but negative 3 is not less than negative 3. So the line itself, any point on the line, is not a solution. If it had been less than or equal to, right, less than or equal to, it actually would be a solution. So we can actually draw the solid line, and that represents that every point on the line is a solution. The last step is we're going to decide whether it's shade to the left or the right of the line. So, like we talked about before, there are an infinite number of points that work. It's not just numbers on the line. If you pick 0, not only does negative 4 work, but negative 5 works, and negative 6 works. So we have other points in here that work. So we need to find those points. So what we're going to do is we're going to pick a test point. Now, the most common test point to pick, right, and it doesn't have to be this, is 0, 0. And the reason 0, 0 is the most common is because often it's the easiest number to put in. So we're going to take 0, 0. 0, 0 is right here. And we're going to put it in to our equation. 0 is less than 0 minus 3. 0 is less than negative 3. Now, is that true? No. That's not true. That means that 0, 0 is not a solution. It is on this side of the line, and it's not a solution. That means all the solutions are on the other side of the line. So we're going to shade the right side of the line. Now, if 0, 0 had worked, we would just shade the left side of the line, right? If 0, 0 works, we shade the side that 0, 0 is on. If 0, 0 does not work, we shade the side that it's not on. What we have here is a representation of all the points that work, no matter what we pick. Let's say we pick this, it would work in our inequality. If we pick this point, it would work in our inequality. This point, it would work. If we pick this point, we know it would not work, right? This point would not work, and all the way up until the line. And in this particular case, the line does not work. Okay, now we're going to go ahead right to practice problems, right? So this is the other problem that was on the first page. Give this a shot, right? So make sure you think of the 3 things you need to do. You need to graph the line as if it was an equation. You need to decide whether it's dotted or solid, and then you have to decide whether to shade on the left side or the right side. Okay, give it a shot, and then come back when you are complete. Okay, great. So we're going to go ahead and graph this as if it was 2x plus 3y is equal to 12. So we're going to graph it right in standard form. There's absolutely no need to change this into slope-intercept form. Just graph it in standard form. So if x is 0, the 2x will cross out, and we get 3y is equal to 12. Y would be 4. Now, pick 0 for y. The 3y cancels out. You get 2x is equal to 12. And we get 6. So we get 2.0460. Okay, all done. So there's your line. It goes through 0, 4, and 6, 0. The second thing we're going to do is we are going to decide whether or not it should be solid or dotted. So we'll look at the inequality sign. It's a greater than or equal to sign. So that means it's a solid line. If we were to pick a point right on the line, like 0, 4, it should work, right? So if we just check it, we don't need to, but if we check it, 12 is greater than or equal to 12, yes, it does work, so a solid line is appropriate. Now, let's actually pick a test point, 0, 0. So I'm going to pick this point right there, that's my test point. If I put 0 plus 0 is greater than or equal to 12, that is not true. That means 0, 0 does not work. We want to shade on the opposite of the line from where 0, 0 is. Don't make the shading super complicated. Just do a simple crosshatch, that's fine. One last point. There's only one time that you can't use 0, 0 as a test point. And that one time is if the line goes through 0, 0. If the line goes through 0, 0, you have to pick a point that's not on the line. Otherwise, you can always pick 0, 0.